Hello Cloud Gurus and welcome to this lesson where we're going to spend some time looking at VPC flow logs. And VPC flow logs are a critical technology to understand for the exam. When I sat the exam, I had a number of questions surrounding VPC flow logs, so it's pretty essential that you understand the architecture, how to read the log files themselves, and then how to troubleshoot any problems involving VPC flow logs. So let's get started. So let's start with the basics. What are VPC flow logs? A flow log is a logging entity within AWS which captures the metadata of IP traffic passing through an entity to which it's attached. So that's a critical point. A flow log is attached to something. Now, to reiterate the above point, a flow log is not a packet capture tool. A flow log monitors metadata, so data about data. It's not capturing the actual IP data, the contents of the IP data. That's not what this tool does. Now, this means that we see information on IP traffic being monitored, such as its source address, its destination address, its source and destination ports, and its protocol. And they're just a few of a wider selection of elements which are monitored. I'll detail the other elements shortly, but just understand it's not the actual contents of the data that's being logged. It's relevant metadata about the data. Now, I mentioned a second ago that a flow log is a logging entity which is attached to something. Now, these somethings are ENIs, so Elastic Network Interfaces, subnets, and VPCs. And when they're attached to those things, they're monitoring traffic scoped to that thing, so the network interfaces in that thing. So if you attach a flow log to a VPC, then it monitors all interfaces within that VPC. If you attach a flow log to a subnet, it monitors all network interfaces in that subnet. And obviously, if you attach a flow log to an Elastic Network Interface, it just monitors that Elastic Network Interface. Now, flow logs monitor ingress and egress traffic scoped to the thing to which they're attached. And they can also be configured to only log accepted traffic or only log rejected traffic, or they can log both. And that's configured on a per flow log basis. Now, a crucial thing to understand is that this configuration can't be changed afterwards. Once a flow log has been created, it's locked. Changing it means deleting it and creating a new one with the desired configuration. Now, you also need to understand that a flow log is not real-time. You might be tested on the exam, so it's a critical learning objective. Flow logs are not suitable for real-time traffic analysis, and they don't capture traffic. Logs themselves can take several minutes to activate. They don't show data before their activation, and any log entries are added when they arrive. It's not real time. You'll see that ingress or egress traffic to and from an interface generally doesn't show up in a flow log for several minutes. Now, a flow log stores the data that it manages in CloudWatch logs. By default, a flow log has no permissions, and it needs to be given them via an IAM role. And the flow log assumes that role to gain access to inject data into CloudWatch logs. Now, each flow log is configured to use a CloudWatch log group. You can select an existing one, or you can create one. A flow log maps on to a log group, and that's an important thing to understand. Now, each entity that a flow log identifies traffic to and from, so network interfaces in a VPC, subnet, or a specific network interface, is mapped on to a dedicated log stream within that log group. So that, at a high level, is what a VPC flow log is. Now let's move through the next set of slides looking at how you set a flow log, where you access the flow logs, and then what the data that a flow log collects looks like. There are a number of ways to access your flow logs. If you've applied a flow log to a VPC, then you can select the VPC and select the flow logs tab. And you can also create a flow log from this location using the create flow log button. Now, you can see information on your screen now relating to a specific active flow log that I have configured in a test account. You can see the flow log ID, the filter column, which lists whether this flow log only shows traffic which is accepted, rejected, or all traffic. You can see an IAM role ARN for the flow log. You can see the creation time of the flow log and the status, in this case it's active. And you can see the CloudWatch logs group, which this flow log is using to store its data into. Now also pay attention to the inherited from column. The flow log that you are looking at on screen is directly attached to a VPC. It's a VPC scoped flow log, and so it's not inherited from anywhere. But you can also apply flow logs to subnets, and you can also view the flow logs that apply to a subnet. In this case, by selecting a test subnet in the US East-1A availability zone and selecting the flow logs tab, we can see two applicable flow logs. The top one is a flow log which is directly attached to this subnet. Note that it has different filters from the bottom one. In this particular case, this flow log, which is directly attached to this subnet, has an all filter. In other words, it shows all traffic, whether it's accepted or rejected. The bottom flow log is attached to a VPC, which this subnet is a member of. And we can tell that because it has an entry in the inherited from column. In this case, we can see that this flow log has been inherited from VPC-7 Alpha 07 Foxtrot 41 Echo. And this means that it's scoped to the VPC, but because this subnet is in that VPC, it inherits it. And this flow log logs all of its entries to a CloudWatch log group called FlowVPC, and it's using the accept filter, so it only shows traffic which has been accepted. And the same principle applies for ENIs. You can select a specific Elastic Network interface, go to the flow log tab, and look at any directly scoped flow logs, and those are ones which are attached directly onto the network interface, or ones which have been inherited from the subnets which those Elastic Network interfaces are in, or higher up in the chain from VPCs which the subnets are in, to which those Elastic Network interfaces belong. So you can potentially see two levels of inheritance on an Elastic Network interface, the VPC and the subnet. And then of course you'll see the ones that are directly attached, and they won't have any value in the inherited from field. Now moving on to CloudWatch logs, I mentioned that each flow log was linked to a log group. When you're creating a flow log, you specify the name of a log group, and it's either an existing one or one which it will create. Now in this example that I'm going to show shortly, I have a flow log called FlowVPC, and it's configured to output its logs to a log group also called FlowVPC. In the VPC, which this flow log is scoped against, I've created two EC2 instances. I've connected to both with SSH and left them running for a while to generate some additional traffic. The result was two log streams in the log group, one for each of the Elastic Network interfaces connected to the EC2 instances. Note how the log stream name is suffixed by -accept, and this is because this flow log is configured to filter only accepted traffic. It could easily be -all and -reject, depending on the flow log configuration. Now if we enter one of those log streams, we're presented in the GUI with something that looks like this. And this is flow log data for a specific Elastic Network interface. It's a network interface attached to one of my EC2 instances. Now let's look at the structure of a flow log item. You'll get questions in the exam where you need to be able to review, understand and act on this type of data. You'll need to be able to interpret it effectively and identify a problem and then pick a suitable fix. So understanding the log format is essential. This is the raw metadata for one of the above log entries. And I'll cheat, I'll let you know that this is actually an incoming SSH connection from a public internet IP to one of my EC2 instances. But let's look at each field one by one. The first field is often confusing if you're trying to interpret a flow log for the first time. It's simply the version of the flow logs, in this case version 2. It doesn't relate to traffic in any way, so from a network diagnostics perspective, it can generally be excluded from your processes. The second field is the account number that the flow log belongs to. In this case, it's one of my accounts, a development account. This field may be more useful than the Flowlog version, but still, it generally isn't directly needed for network fault finding. The next field is the network interface for which this log stream, and thus traffic, relates to. In this case, it's an ENI attached to an EC2 instance in one of my development AWS accounts. The next column is the source IP of the traffic. Now logically, it will be an internet address, so a public IPv4 or 6 address if the traffic is ingress or inbound traffic. And it will be a private IP address of an AWS service such as an EC2 instance if it's egress or outbound traffic. Now note, and this is a critical learning objective, the Flowlog will always show the internal addresses of any AWS services, even if they have public or elastic IP addresses. And also, it will always show the primary private IP address on the Elastic Network interface, even if the traffic is going to or from a secondary IP address on an Elastic Network interface. It will always show to or from the primary address. Keep this in mind for the exam. Now next, logically, we have the destination IP address for the entry, and the same rules apply as the previous point. If the destination is an AWS service, it will be using the private primary IP address, even if that resource has a public or elastic IP address. And that's because whether the Flowlog is scoped to a VPC, a subnet, or a specific ENI, it's reading traffic to and from a network interface. And at this point, this is before the private to public translation which occurs at the internet gateway in the case of outgoing traffic, and it's after the translation between public and private for incoming traffic. Either way, the entity that obtains or captures this traffic will only ever see private IP addressing for internal resources. And note that it's possible that both the source and destination addresses are private addresses, and this will occur if the traffic is internal to internal, for example between two subnets in the same VPC. Now next we have the source port of the traffic, and in this example it's 54639 on our originating machine. Remember, I've mentioned that this is an inbound SSH connection, and we can tell it's inbound because the source IP address is a public internet IP, and the destination is a private IP address, so an internal IP address. Logically following on from this is the destination port, in this case 22. And this is SSH, assuming that it's using the TCP protocol. The next value along is the IP protocol number. And this is important. There's a URL on your screen now which lists all of the different protocol numbers for the Internet Protocol, so for IP. In this case, it's 6. And if you check out that URL, you can see that 6 is TCP. So we can tell that this is TCP on port 22, which is SSH. The next field contains the number of IP packets measured during the capture window. And more on what a capture window is in a second. But in this example, it shows 12 packets were observed during this window. And likewise, this shows that 900 bytes were observed during this capture window, and I'll explain a capture window in a second. And speaking of the capture window, the next two fields show the capture start and capture end time in Unix seconds. In this case, it's a total of 38 seconds. Now I'll talk about how the capture window is important in a second, but just know that the first number is the start time of the capture window and the second number is the end time. The next field shows the accept or reject status of the traffic. And if you have a filter on a Flowlog for just accept, then obviously you'll only see accept traffic, and likewise with reject. If the filter's set to all, you'll see traffic with both accept and reject. The last field is the log status, and it can be OK, indicating that data is being logged, or alternatively, no data or skip data, which indicates a logical problem, i.e. no data has been received in the capture window, or that we have a problem with the logging system. Now, a critical thing to understand about Flowlogs is that each Flowlog entry, and an entry is the specific line that's in the center of your screen now. One of those entries represents a metadata capture for a specific set of values. So the source IP, the destination IP, the source and destination port, and the protocol. So one log entry represents a unique set of those 5 values for a particular capture window. And a capture window can vary in time. This means that if you have 2 internet hosts talking to your EC2 instance over SSH, you will have at least 2 flow log records. One between the internet host 1 and your EC2 instance, and a second between internet host 2 and your EC2 instance. Now you'll actually probably have 4 because the return traffic will generate a log entry. So the EC2 instance to internet host 1 and the EC2 instance to internet host 2. And then, if the connections last for a long time, so they cross the boundary of a capture window, then you may even have 8 entries, or 12 entries, or 16 entries, and so on, for a particular communication. Just remember for the exam, a flow log record is a record which represents a unique communication between 2 IPs on the same source and the same destination ports using the same protocol for a specific time period. Well, thanks for listening, Cloud Gurus, and this is the end of part 1 of this lesson. If you do have any questions, please reach out directly or via the Cloud Guru forums. Otherwise, feel free to finish this part and continue with part 2.